Hi, and welcome to Behind the Code. I am John Davenport, and today we're going to be taking a look behind the code of ZER0ED, which is a game that I created in October of 2020 and launched on the iOS App Store. Today we're obviously not going to look at all the code. That would take many hours, and my plan is to eventually look at all the code, but today we're going to break it into just one or two subclasses, and we'll take a look at how those work. But before we dive into the code, let me play a little bit of the game just so that you have an idea of how the game looks and what I've created, and then we'll dive into the code. So you have targets, which are on the left and right, and then in later difficulties can be the top and the bottom. Today, we're going to focus on the code of the target. Select them by tapping them, and then you tap on your resource, which is the middle value, to subtract the resource's value from the target. If you tap twice, instead of subtracting that value, you add that value to the target. You can see here, as I'm going through, if I tap once, the value of the resource is subtracted from the target. If I tap twice on a target, the value of the resource is added to the target. And if I make the target's value equal to 0, I score points. And that's kind of the whole concept of the game, ZER0ED. There's some other complications in there. So you may have noticed that after a few moments of not using a target, it will turn red. After it turns red, it will expire, regenerate a new number, but it does reduce your score when that happens. When a target turns green, that's a good thing. It means you've ended the target value in a 5, and that's a bonus score. And then if you end the target in a 7, it turns red, and it will reduce your score, take some fuel from you. Resources as well, there's a few different kinds of resources. There's timed resources, mutating resources, power-up resources, which is one you see right now. Also, there's a bonus resource, which is this one here. If you use it before time expires, you get score and extra fuel. So today, we're going to dive into the code, and we're going to look specifically at the targets. It's kind of the easiest place to start. Next week, we'll dive in and we'll look at the code that runs the entire resource generation, and that's kind of the bulk of it. What's happening in the code, the targets themselves only really care about what state they're in, whether they're set to subtract, they're set to add, or they're the default state, which is basically unselected. So we'll dive into the target code today, and then like I said, next week we're going to go into the resource code. So let's take a look at code now. All right, so now that you understand a little bit of the gameplay, today what we're going to be talking about is specifically related to the functions of the targets, which are the pieces on the outside, so the left, the right, the top, and the bottom, if you're on higher difficulties, and how it's structured and how basically the game logic operates around those pieces of the game. So the first thing that you can see here is we have a subclass of an SK sprite node called target, and this is what handles most of the logic behind the targets themselves. So the first thing that we do is make sure that they're clickable, and that we create a delegate for that. And then we set up a few other variables just to get initial variables here. The one interesting aspect of the target is that it actually isn't a sprite. It doesn't have a texture. So even though it's an SK sprite node, the look of it is all based on emitter files. And I can show you those now. So you have the default emitter file, which is the purple pinkish color. And then we have the subtraction. So if you tap the target once, you'll see this red color, which indicates that you're going to subtract that target's value. And then if you tap it again, we get the addition emitter here, and that's this green color. And then if you end your target on a 5, so 5, 15, 25, you get the bonus effect, which is bonus points and bonus fuel. And then the opposite, if you end up on a 7 or 17, 27, and so on, then you get the penalty effect, and that's this color here. And then there's one final emitter, which is the warning that the target is about to expire. So at 5 seconds to expiration, the targets will turn a color, and it'll be this emitter node that you're seeing instead of the default one. So let's take a look at how the targets all work in code. So after we do some initialization and everything, there are only a few main functions here. The biggest one is going to be the isSelected function. So every time we come into this function, and you'll see where it's called in a second, but every time we come into it, we're going to increment the current state by 1, and we're going to make sure that that never goes to more than 3. So if it's greater than 3, we're going to set it back to 1, and that will allow us to use a switch statement to basically toggle the visual aspect of the target from the default mode to the subtraction mode to the addition mode. And you can see all I'm doing here, I've already added the emitters to the scene. They're just hidden. So when we tap into case 2, which is the subtraction mode, you can see I'm basically saying that emitter is now not hidden anymore. So it will display, and then we play a sound. Again, when we tap one more time, we toggle them so the subtraction emitter is now hidden again, and the addition emitter is no longer hidden. And then if we tap it another time, it will go to 4, which then will set it to 1, which means it'll come into case 1, and both the subtraction and addition emitter are now hidden, and the font color is set back to black for that particular emitter node, because you can see here we set the font color to white when we're in one of the other ones, and that's just for readability purposes. So that's all that's happening in the isSelected function. Basically, we're just toggling between the 3 different states that the player can toggle. So then we have a reset state function here, and this function is basically just designed to make sure that after the player performs their action of selecting the resource and doing their subtraction, that the targets are then reset to their original state. So it sets the current state to 1, and then it changes the font and makes sure everything that could be hidden is hidden. It'll restart the timer based on the difficulty level, because if you've used the target, then the timer gets reset, and so on and so forth. And then we have another function here which handles how the value of the target is calculated and determined. So you can see here, basically the game is set up so that the target, when it's first created, it is created between 15 and 30. So you can see here where the maximum value is 31, and we're going 15 to less than the maximum value. So 15 to 30, and then we ensure that you don't get a penalty or bonus off the start by recalling this function. So the function basically will call itself if the value that it had picked originally ended in a 7 or a 5. Otherwise, the target value equals whatever random number was picked there. So that's a pretty simple function. We're just getting a number and assigning it to the target. Now we need to handle some of the target updates. So this is going to be things like make sure we track the value of the target as the resource is subtracted from it. We come into the update function here. This piece here is just for the tutorial purposes. There's a piece of the tutorial that needs this, but otherwise it's really just disregarded, because the value that we're passing through is the value of the resource, which is never 0. So this should never happen. But anyway, it's there just as a precaution, I think, for the tutorial. So the target value is updated by the value. So whatever value we pass through, we subtract from that target value. The way we handle addition is we basically pass a negative number. So if you subtract a negative, you do an addition. We need to make sure that if the particle emitter is currently a penalty. We need to clear that and reset the default emitter file. Same thing here with the bonus. If it's currently in the bonus state, then we need to reset that. And then we need to check the target and make sure that if the target equals 0, then the player is given a win. So we set win equal to true, and we reset the target's values. And then here we're looking for when the target is updated. So you're subtracting a number from a number. If that number ends in a 7, then we lock the target, and we make sure that the second file name, which is the penalty file name, that's the one that's going to be picked. And we'll have that emitter node displayed. Same thing goes for when it's a 5. So we're going to display that. We always, every time we do this, we're removing the current particle emitter. So we come in, we remove the particle emitter because we can't just change it, right? It's a thing. So we have to remove it and then add a new one every time. That's how we're handling this whole thing. So you can see here, otherwise, if the target is in the default state, then we're just going to ensure that it's not locked and make sure that the font color is black. So nothing really happens there. There's only a couple more, or really one more piece here, which is the update timer function. And all this really does is handle displaying the warning to the player. So when there's less than 5 seconds left and the current warning is set to false, we make sure that we set it to true. We have this here to ensure that it doesn't constantly, because if you just have it at less than 5 seconds, then for 5 seconds it's going to trigger this over and over and over and over again. And we don't want that, because you can see here we're removing the particle emitter and then adding a new one. And if you constantly are adding it for 5 seconds, it becomes a problem. So we set the warning active to true. That prevents it from coming in more than once. And then once the timer runs out, it will call the reset target values function, which will then, basically we just reset everything. And that you'll see in the game scene, which we'll look at now. So first things first, we need to do some initialization. So we have the positions of the targets. We add them to the scene. We're going to append them to level targets so that we can search the targets for various things throughout the code. And you can see here the first time we do that is right away, where we're basically assigning a physics body to the target. We're giving it a Z position. We're setting the target values. So that was one of the functions we had seen before. We're making sure that it has the delegate. We're letting it be user interactable. And we're setting the label of the target to be the target value that is picked, which is picked here, and then assign, and so on and so forth. And then we come down here, and we are assigning collision and to the level targets, basically collision and category bit masks. That I'll explain in a little more detail in another video, because the physics and everything gets a little more complicated. So we'll go into that in a future video. So initially, there's only 2 targets. So the top and bottom one are going to be hidden initially, and then that's how the easy mode is always just those. And then if you play on hard or insane mode, the top and the bottom target will be unhidden eventually. Let's take a look at what happens when the player clicks on the target itself. The first thing that we do is we want to count how many targets are locked, because if you have a 5 or a 7 on the board, then you are forced to use only those. You can't use something that's not a 5 or a 7. So what we do is we create a new variable and we set it to 0, and then for all of the targets we count, or we basically search through them, and then if it's locked, bool is triggered to true. If the target's actually locked, then we increment this new variable that we just created by 1. So then what we do is, if the target's locked, so if that's greater than 0, which means it's 1 through 4 basically, then we know that a target is locked. So we're going to come in here and we just have it set up as a if-else statement. Basically, if the target is locked, so this is the specific target, right? The target that's being tapped. If that target is locked, then it's allowed to be interacted with. Basically, we create a generator for a light haptic touch, and then we call the isSelected on that particular target. So if the target's locked, then it can be interacted with. If it is not locked, so if that search returns false when you tap the target that you're tapping, if that comes back as false, then this is basically just empty. So nothing happens. You can't interact with that target because you're in this if statement here. We know that there are locked targets on the board. So you can only interact with the targets that are locked. If there are no locked targets on the board, then it doesn't matter which target you click on. We just again, we assign that generator to create the light haptic touch, and then the target that's being tapped, whichever target it is selected, and that, as we saw earlier, is just toggled between the 3 states. So as you can see, the function for the target itself, when you click on the target, it really just handles the target that can be selected, is able to be selected. And if there are locked targets on the board, then those are the only targets that can be interacted with. As you can see here, there's not a whole lot that goes on with the targets. Just a little bit of logic to ensure that the player can interact with them, that their values are updated and tracked, and that their state is tracked and displayed properly. The bulk of the logic for this game occurs when the resource is tapped, and we'll take a deeper look at that aspect of ZER0ED in next week's video. So I want to thank you for watching today. I hope you like this deep dive into the code of ZER0ED. If you do, please click that subscribe button and tell your friends about this channel. I hope to see you in the next video.